Hey everyone. In this video we're going to be looking at standardizing a base solution by titration. So in this problem we have a chemistry student needs to standardize a fresh solution of sodium hydroxide. She carefully weighs out 137 milligrams of oxalic acid, H2C2O4, which is diprotic, and can be dissolved in 250 milliliters. The student then titrates this oxalic acid solution with sodium hydroxide. When the titration reaches equivalence point, the student finds that 133.6 milliliters of sodium hydroxide has been used. And we want to calculate the molarity of the sodium hydroxide solution that she used to titrate. So remember that molarity is denoted with a capital M and stands for the amount of moles per liter. So right off the bat we can see that we are given liters already. So 133.6 milliliters of sodium hydroxide is used, so we have our L, which can be expressed as 0.1336 liters. And so all we need now is to find out how many moles were used in this titration. And to find out how many moles were used, we can find out how many moles of the acid were used in the titration. If we know the amount of moles of acid we can use in the titration, then we can use the mole ratio of a diprotic acid, which we discussed in the last video, in order to find the moles of sodium hydroxide used. So just a quick refresh from the last video. I'll put the link to the last video in the description below, just in case you want to review. But essentially, an acid is something that accepts hydrogen ion and a base, or acid donates, and a base accepts. And so in this example, we have example of a diprotic acid, where if you write out the balanced equation for the titration, you'll see that 1 mole of acid is used for every 2 moles of base, making the mole ratio for a diprotic acid a 1 to 2 mole ratio for acid base. So once we know the moles of acid in our solution, we can multiply it by 2, and that will be how many moles of base is used by the time the solution is titrated. So if we're given an amount of grams here, and we can convert that by dividing by 1,000, we know that this is 0.137 grams of oxalic acid. All we need to do now is use the molar mass of H2C2O4 to find how many moles of acid we have. So the molar mass of H2C2O4 is going to be 2 hydrogen molar masses plus 2 carbon molar masses plus 4 oxygen molar masses. And if you calculate that, we can find the molar mass of oxalic acid to be 90.03248 grams per mole. So now that we have that, and we also know that we have 0.137 grams of our acid, we can then use the molar mass as a ratio. We know that 90.03248 grams is in every 1 mole of oxalic acid. And as we've done many times before, the grams will cancel, and you will be left with 0.00152,167 moles of H2C2O4. So I'm just going to take this value, move it down here for more room. And so now that we have our moles of acid here, we can multiply it by the mole ratio for a diprotic acid, which we found to be 1 mole of acid for every 2 moles of base. So 1 mole of acid will be put on the bottom so we can cancel. And for every 1 mole of acid, we have 2 moles of base, which is NaOH. So moles cancel, and we are left with 0.00304,335 moles of NaOH. And now we have moles. So if we're looking for molarity, all we need to do is divide this number by however many liters we have. So if we go back, we see that 133.6 milliliters of sodium hydroxide was used in this titration. So if we divide by that amount of liters, then we get that our molarity, M, is equal to this number divided by that number. And that's going to give us 0.0288. Oh, actually I was right the first time. 0.0228. And this is moles per liter, which is capital M. And that is the molarity of our base solution that was used to titrate our oxalic acid. And that's all for this video. Hope you learned something. Thanks for watching.